So not invented here is far cheaper than the wrong dependency. This is blog post written by Luis, and I would like to take a look because yesterday I was dealing with dependency hell, and I think this one hits pretty much home. So let me see what he has to say. One of the biggest fallacies in coding is that dependencies have zero downsides. It's treated as free functionality you don't have to write yourself. Wow, what a deal. Yes, that's usually true. I think everybody treats dependencies like free functionality. Um, Everybody says that you should at least take a look into the source code of these dependencies, but just let's be honest, nobody really does that. And I've seen senior developers, junior developers, like it's always the same. You will just take the tool, do your job, and pretty much move on. And yeah, and that's about it. Okay, so let me continue. But the dependencies have absolutely have a cost. Okay, they may require significant time investment to learn to use. Often they are large and complex that simply writing the functionality yourself is faster than learning. Sometimes it's easier to write it yourself than install the dependency. Yeah, I think I disagree a little bit here because usually it's not faster writing it by yourself. Um, that means that, let's say, if you are taking a larger dependency like table management in your UI code, like that's something you can't write yourself faster than the library, than learning the library. But yeah, like there are cases where you need just one or two functions from the library, and in that case, you definitely should write it yourself if that's a couple lines of code, and it's much better to own it yourself and maintain it by yourself than in 2 years dealing with some changes in such library. Okay, continuing, their breaking changes can trigger expensive rewrites of your own code to handle new interface. Yes, you need to ensure they end up on your client's machine. Now, yes, that's true. Let us consider this last point. How many absurdly complicated content iterations or bundling setups do we encounter in our work because someone does not want to reinvent the wheel and instead opts to use large complex dependencies? How many times did people take the time to appreciate they reinvented an entirely different wheel that has nothing to do with their app's core functionality just to deploy and run the bloody thing? Yeah, this is usually true. Like I've seen this dozen of times, but the counterpoint I think here is that we started to care a lot less. Like that's true. Like everybody wants to just get their work done and move on, and um, I think it's very rare when you encounter a team where everybody is on the same page when it comes to like craftsmanship of the software, right? So I think this is more the like the structure and people problem than the software problem itself. But I think the number one issue here, what the author tries to say, is that we are just piling the software stacks on the top of each other, and yeah, and making it like horrible experience for everybody who comes after and try to like, okay, why do we have these dependencies in the project? What does this thing do? At the end of the day, you will figure it out that one of the dependencies just does one silly thing that could be like sidestepped entirely, but it is here. Nobody wants to touch it, and yeah, like that's it. You have a complicated system. It's so simple. Um, okay, so we are moving to the next point. Instructive here is Tiger Beetle, a financial database written entirely with vanilla Zik. I want to point out that Tiger Beetle is a really cool project. You should definitely take a look into, and the Matclad, like the maintainer or founder or co-founder, is a really good guy and has some nice blog posts. Tiger Beetle has zero dependencies policies apart from the Zik toolchain. Dependencies in general inevitably lead to supply chain attacks, safety and performance risks, and slow install times. For foundational infrastructure in particular, the cost of any dependency is further amplified throughout the rest of the stack. Similarly, tools have costs. Yeah, I will stop right there. I agree completely with this statement, and I would be like much happier person if Node community would take a similar approach here. Because if you tried run a project from 2 years ago or 1 year ago in Node ecosystem, you will definitely encounter some issues. And it's issues like mismatched dependency versions. There are like you will run the audit command, it will yell at you that there are a couple of dependencies that are like out of date and vulnerable, and like you have a feeling like you are standing on a quicksand basically in Node ecosystem. Like it's not given that if you visit your project in a couple of months that everything will be the same. And I think this zero dependency policy is like an antidote to this, because when you think about it, like tool chains may change, but I think everybody is thinking about their tool chains or build tools as something that should have like backward compatibility, and at least you should be able to build your project with the tool chain in that version. Like building a project in Zik from with like today's toolchains version should be possible in 10 years, and there shouldn't be any problems with it, which we can say about any dependencies you will install into a project. So yeah, I 100% agree that tools have a cost, and we should treat it as such. But again, like to the previous point, everybody is trying to have like as easiest as possible experience when they try to develop something, I guess. So installing a dependency is really quick and easy. And I think Odin, the new language, has this like kind of feature where installing a new dependency is harder than let's say in Rust or Node. So you don't end up with thousand, but basically you can end up with hundreds of dependencies if you consider dependencies of each dependency and the entire dependency tree. So it's very easy to install a bunch of stuff you don't really need. So we are continuing. A small standardized toolbox is simpler to operate than an array of specialized instruments, each with dedicated manual. Yeah. Our primary tool is Zik. It may not be the best for everything, but it's good enough for most things. We invest into our Zik tooling to ensure that we can tackle new problems quickly with minimum of accidental complexity in our local development environment. Yeah, like that's all good. I think it may bring some pain points forward when you are using the one tool you have for everything, but in the end, like you are the maintainer of your own software, so you should be happy about the maintainability at least. So it should be easier to understand the entire project when it is written in one tool and everybody on the team understands the tool and knows how to use it. So that makes sense. And I'm glad that this zero dependencies policy is something that is like brought forward. Okay, a framework for evaluating dependencies. Okay, this will be nice. I am aware that this poses reductio ad absurdum magnet. What so you make your own silicon wafers? Yeah, in ideal case. Yeah, like you need to stop somewhere. Programmers of certain generation might bring up a webcomic and butterflies. Ultimately, we all depend on something, but not all dependencies are created equal. Allow me to introduce my framework for evaluating dependencies. Okay, so 5 categories. Ubiquity, how widely available is it? Are target environments likely to have it pre-installed? Will we need complicated deployment with container bundling? Okay, so this is like the, I guess, base layer. Stability, or not base layer, but like you want to use tools that are basically everywhere or at least well known. Stability, how frequent are breaking changes, deprecations, or shifts in the meta? This one is tough because you can't really predict like the stability of a library. If you think about it, like if there is a like my JavaScript brain is yelling at me right now, but there are always new stuff. There is always new stuff that is available. So maybe that's the stability argument, like not using the new stuff, I guess, in this case. Depth, how much functionality lies beneath the API interface? How much harder would it be to do without the dependency? Okay, and ergonomics, is the abstraction provided declarative? Is the API pleasant to use? Yeah, like this one is super important, I think. The ergonomics part, and I will talk about it after last point. Water tightness. Does the abstraction leak? How often must you consider the underlying technology? Yeah, like that's one. I guess that's the hardest one to evaluate, I guess. But let me talk about the ergonomics. So you will install a new dependency into your project, and the last thing you want to deal with is like wrong ergonomics, which in my in my translation, or I would translate it into like how easy it is to integrate the library into your like existing application, and if it makes sense, like how how the library is written. So common issue with ergonomics is when you have SDKs. For example, you try to work with Google services, and you can either communicate with them via REST interface just by HTTP calls, or you can install their SDK. And you will see that sometimes the ergonomics of these SDKs, because each SDK is like targeting a different language. So you may see in the wild that somebody will write an SDK for Node.js, but they will port like the entire same function naming and stuff into the Python, and it will like it won't make sense in the Python like ecosystem. So that's the ergonomics part, I think. And yeah, like that's what I considered to like using APIs that are pleasant to use. So it makes sense with the language ecosystem and your. So for example, Laravel is great at this. Like they are providing you a bunch of like first party libraries that you can use, and that's where the ergonomics shine, because it's basically all the parts are or all the parts fits together greatly. So yeah, so that's it. And water tightness, does the abstraction leak? How often must you consider the underlying technology? Um, so example that I think author is talking about is like if the dependency has like some kind of other system dependency, which you need also to install when you try to use the dependency. I think the um, good example may be some Python dependencies that also install a bunch of like C, C++ kind of like static libraries. And yeah, I think that's it. And it is very annoying when you need to deal with these. That's why I consider, for example, Zik to be great at like integrating it into the like C projects, because you can just install the Zik compiler and also compile C files, which is great, because you don't need like another thing to work with C files. Everything is included in the Zik toolchain. Okay, so dependency peddlers typically only talk about ergonomics, and I ignore other criteria. Yeah, that's. I think I was called out here. Yeah, yeah. Usually ergonomics is number one thing everybody is considering, and that's, I guess, I also end up in the bad state. With that in mind, let's evaluate some dependencies. Good dependencies. POSIX system calls. Mm, yeah, so POSIX system calls can be used on Linux. Yeah, that's true. Android, macOS, BSDs, etc. Stability XRM is stable. Breaking changes are rare. Yes, that would be really annoying if it wasn't the case. Depth incredibly deep. A single open call hides hundreds of thousands lines of kernel code. Ergonomics mediocre. Uses many flags and old school C conventions, but not terrible. I think it's sometimes can be pretty terrible, but you can always like build like it's it's not terrible enough that you can like sidestep it with your own abstractions, and that's literally what every other programming language do. Um, Water tightness mostly good, though the storage devices can their own conceptual of what persisted means. Okay, yeah, that makes sense. ACMA 48 terminal control codes. Ubiquiti other than CMDX XZ in Windows. I can't think of major terminal emulator that doesn't respond to these. No changes to the standard since like the stability is nice, but I always think about like what to do when we want to move forward. Like should we invent like entire suite of new tools or should we just accept it? This is the standard. Like I'm not sure right now, but I'm for like moving forward and breaking more stuff so we can have much nicer things. But then I will probably end up in dependency hell, so my bad. That the alternative I think would be to make your own standard for character frame buffers, not an impossible task. Yeah. Let me check what the depth. Yeah, so how much functionality lies beneath the API surface? How much harder would it be to do it without dependency? Yes, like this would be, but again, like if this is something that never changes, so you will probably also write the if you were to write it yourself and it would never change, like that's the thing I guess what should be considered like the perfect dependency, because you are just implementing a thing and it's complete. Like there will be no changes, no updates ever. So in that case, you can just take it as maybe as a take it also or render it as a your dependency in that case. Uh, so the depth, I guess the depth can like it has much more weight in my eyes now if I think about it. Ergonomics not all that bad if you can ignore the line noise. Yeah. Water time is very good. Very little you need to care about the hardware your terminal emulator is running on. Yeah, that's correct. The web platform, web APIs, HTML, JavaScript, CSS, etc. Ubiquiti, the web browser is mostly used. Yeah, it's basically used everywhere. Yeah. Stability, fairly big commitment to backwards compatibility. I can stroke. Yes, and I think this one is also like its weakness, but that's on like I would talk about it later. Depth, very deep. Writing your own browser to render your page or website is not feasible. Yeah, that's correct. Ergonomics, they are all right. They are all right. The web platform ergonomics are all right. Okay, some craft, but the documentation and developer tooling is excellent. Yeah, like it's like all the good stuff like web inspector and even the Chrome debugger, console logging and all this stuff. Like it's pretty nice. Like when you try to develop something on for the browser and then move to the I don't know like development for Mac OS, like you will quickly run into some like annoyances where okay, so I change this, now I need to like rerun the entire application, get to this state where I care about like what I want to test, and the iteration will be much larger than on the web. So I think I'm just mm, I'm just thinking of all the bad stuff that like how the DOM model works and how we try to like make it for applications, and it's I think it's not that great in this regard, but the developer like ecosystem around it is like one of the best because let's be honest, like no other ecosystem has that amount of investments like coming into it as the browser. Watertightness outside of maybe interacting with files, audio, video, it's pretty watertight abstraction. Yeah, like that's correct. I like there are other like I'm not sure if watertightness or where should I put like the um, differences between browser vendors, like if it's in the watertightness category or not, because they're like yeah like you can run browser on pretty much anything. You don't need to uh, like expect that user running your website has installed some dependency on their system. Like that's true. But sometimes you want to like I would put that like if you want to use some features from Chrome that are not available in Firefox, like you can't use them at all, which is shame. Or you can do something like but nobody does that. Like feature flag it, or like there is a API for checking if the feature is available on the browser or not. Bad dependencies. I will leave this as a I will leave this as an exercise for the reader, but remember, think critically, evaluate the costs as well of the benefits, and choose wisely. Yeah, so let's talk about bad dependencies. Like I think I don't have any like on my mind right now, but I think bad dependencies usually solve solve the problem. Like every dependency should solve a problem, right? Like every package you want to install should solve a problem. Uh, but I think maybe we shouldn't call like all bad dependencies because sometimes somebody is just solving their own problem and that they are just sharing it with the world, and basically it's your own fault that you're trying to use it because you didn't go through these steps. So maybe bad dependencies is same concept as bad evaluation of dependency, because um, like nobody is forcing you to use anything, right? Um, the problem with bad dependencies can be when you are like required to use some platform specific SDKs. So for example, you want to build a user interface that looks native on Linux, and you are forced to use GTK to be like closest to the like visuals and the native look. And that can be considered like bad dependencies. I don't want to criticize GTK itself, but that's just an example when what should be like considered bad dependencies. But in that case, I think it's more of a platform software. It's not even dependency because you can really like avoid it or sidestep it, which is shame. So yeah, I think I agree with almost everything in this article except a few little points. but it was nice reminder for all of us that we should like not just install everything we see on the internet and just move on, but evaluate all possibilities, which shouldn't take that long, right? If you think about it, like, okay, I need to do something. I think I would I like, you need always like start with depth, I guess, because you need to like figure out, okay, what it would take to do it like in house, and you can go from there, because usually if the answer is like it would take weeks or months, okay, we can now enter the, okay, what dependency we can pick, and you will go through all available like dependencies, and then you need to look into it, okay, which one are actually maintained, which one are like actually used, and from then like which are unstable. Like, you will quickly go through this funnel of like decisions, but in reality, I guess you don't have that many choices. Like, if you want to work with PDFs in PHP, for example, like, you will quickly realize like there are 4 or 5 options, but at the end of the day, like 1 or 2 are actually viable, and the differences between them is in a very like specific niche situation. So if you want to render HTML into PDF, like you can use both of them. So that's eyewear when you that's the place where you need to like or dive deeper into the library itself. So it makes sense for you to evaluate, or the evaluation will be like complete at that point, so you can decide, okay, I will use that because this and that. So okay, what do we have here? What can we do next? So I will check if somebody is here. Yep, all looking good. So I would actually go, I think this is the Tiger Beetle document. It is talking about dependencies, but I'm curious like what they have here. Simplicity and elegance. Why have style? Okay, so I would gladly look into this too. Let me update the title. Mm-hmm. Okay. Okay, so this is the guy I was talking about before, Matt Clad. Not sure how to pronunciate it, but the Tiger style. So this is document in the Tiger Beetle project, and if you don't know Tiger Beetle, it is a financial transaction database designed for mission critical safety and performance to power the next studies of all OLTP, which is online transaction processing. Yeah. yeah, and there is like some like it's very specific like application, which makes sense that we have like specialized software for it. I'm really glad that they take the time, study the domain, and like haven't settled with just the existing solutions, but thought about okay, so what we can do differently as let's say SQL, other SQL solutions, and they've decided to build the Tiger Beetle in 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 in, in Zik, and this is their style document. So it's pretty common to have style. It's pretty common to have style document um, in your project, but it's not that common that it is actually followed. So what you want to do in that case is usually want to have correctly set up all the like infrastructure of your project. So when you care about like this is the high level document, right? This is not talking about like linters and oh it is actually uh, it is actually talking about some like how should you structure your code, which is nice. But usually you want to also have some kind of linters and checkers that will run after you push some code. Okay, so I'm pretty like I want to know about the technical debt. That's usually number one like problem in almost any project. And then let me see, is there a table of contents? Yeah, it is. And after that, we can also look into performance, I guess. But the essence of the document, um, it's a collective give and take at the intersection of engineering at our numbers and human intuition, reasons and experience, first principles knowledge. Okay. Yeah. So it's like more of a philosophy or how they are thinking about the act of writing of code. Yeah. So let me look into the tech tab. What could go wrong? What's wrong? Which question would we rather ask? The former because code like steel is like expensive to change while it's hot. Yeah, that's interesting. What could go wrong? Yeah. A problem solved in production is many times more expensive than problem solved in implementation or problem solved in design. Yeah, that's correct. Uh, since it's hard enough to discover showstoppers, when we do find them, we solve them. We don't allow potential man copy latency spikes or exponential complexity algorithms to slip through. You shall not pass. uh, in other words, Tiger Beetle has zero tech debt policy. Okay, that's interesting. I think I like this even more than the zero dependency policy. We do it right. Oh, we do it right the first time. This is important because the second time may not transpire, and because doing good work that we can be proud of builds momentum. Yeah, that's true. Like there is like when you think about it, like every time you need to stop and go fix some other stuff, in the code, like it's like small cut to your soul, right? And usually in bigger projects, like what will start to happen is that you will try to implement new stuff. The old stuff keeps like breaking, and you will juggle number of tasks always. That some are like fixing old stuff, something is for developing new stuff, but you will get pressured, time pressured into like building the new stuff faster. So you will cut corners. So you will introduce more tech debt. Like it's so compounding that, but you can't really see it in real time. Like this is the problem with technical debt, that it's very hard to see it in real time. It's very hard to like pinpoint specific code areas in the code. Like okay, this is currently our tech debt, and that's why it is so hard. And also when you are used to the project, you will your brain will also adapt to it. So you will get used to see a shitty implementation of something, because right now you need to do the like implement new stuff, but but the new stuff is getting slow, is being, or it's being bombarded by the old stuff crumbling. Then you need to like cut more corners, so you will introduce even more. Like it's vicious cycle. So I'm pretty interested in like what the zero technical debt policy means. We do it right for the first time. Yeah, like that's ideal. This is important because the second time, and yeah, we know that what we ship is solid. We may like crucial features, but what do we have meets our design goals. This is only way to make steady incremental progress, knowing that the progress we have made is indeed progress. So this is something that not that many developers think about, I guess, because what Matt is telling us here is that they would rather move slowly forward, but they will try to get the software right. And that's, I think it's very rare where the correctness of the software is important as the business goals are. So when you think about it, when you are building some software for a company that is like relying on the software, on that software, like usually you will cut corners to get the value to the business sooner. And what they are saying is that they value the correctness of the software more than the business, because the business will also like benefit from the correctness and craftsmanship of the software, which is pretty nice. And it's very hard to convince like stakeholders usually about this. Like they don't care about quality of the software because they don't understand it, right? So, but I think this is maybe the like most important like mm, like quest for us the developers. Like we need to explain to these stakeholders why tech debt is really bad. But how would you explain something to somebody else who is not technical, that you can't like you can't even grasp it by yourself, right? Like we all know like how it looks like when there is a tech debt in the application, but you can't really show it to somebody. Like you can't really show it to somebody who is non-technical. So then you need to come up with some analogies which they may understand. but um, usually the only way I can I or not the only way, but the way I can maybe communicate it is via like tech debt is something that will slow us down in the future and will make us will make every change more harder and more expensive. So essentially, cutting corners now will not give you any advantage in the future. We may need the features now, like today or tomorrow, but we will need to allocate some time to clean it off, like clean off the all the mess we will make by these rushed decisions. So I think this document is saying in the sense that when you are doing the design and implementation in the right way, right? Like you will think about the problem, you will design it and then solve it. You should avoid a lot of like wasted effort in the future. And you should be like the point of being proud and building the momentum is also like pretty strong. Like that's something also many people don't really appreciate when you are working in a team setting where the code is good, people care about the code, uh, you will start feeling like anything is possible, right? Because you can always like discuss the stuff with others. You will be much more confident, which I would like add into the document. You will be much more confident that you will make the right decisions, and even if you don't make the right decisions, you can always like walk back because you have pretty good um, like process how you introduce new changes. So this is pretty solid, I think, philosophy, and it is something that everybody wants to work this way, but almost nobody is working this way, which is really weird. But it's the impedance mismatch between stakeholders and developers, and I think like when you put the AI into the mix right now, because AI is making everybody a tech person, right? Um, I wonder if it will widen the gap or like bring it closer. So because when you think about it, like when you try to vibe code something, you will quickly get to the point where it is very hard to like make progress when you try to like one shot everything. And I think this may open some eyes to non-technical people who tries to vibe code something, which is nice, which is really nice. So yeah, that's it. And we also quickly look on the performance. Okay, think about performance from outset, from the beginning. The best time to solve performance to get a huge 1000x wins is in the design phase, which is precisely when we can measure our profile. It's also typically harder to fix a system after implementation and profiling, and the gains are less. Yeah, that's obviously true. So you have to mechanical sympathy. You have to have mechanical sympathy, like carpenter work with the grain. Mm, yeah, but I think the problem nowadays is that so few people are approaching the problem from the performance angle. Like if you think about it, like there is so much code like shipped every day into our browsers, so many JavaScript lines, and the performance like bar is pretty low. Like everything is loading constantly. So I'm not really sure like how to fix this, but I'm glad that they try to encourage this mindset, because it's like today, like it's a paradox, because today it's so easy to gain huge gains, because everything else is pretty much crappy. Yet nobody is getting these huge gains because nobody is like thinking about it from this angle. But it should be easy to like for anybody to get some kind of like performance gains if they put a little bit effort into it. So I think the 1000x like performance gains, like that's incredible. But even 2x gains would be incredible, right? So yeah, I think like if you think about developers who have like a tree of skills, like performance is something that at least 10% of thought should be given into, and all the tools and stuff should be like also like put your points into it, but be sure that you have like you are aware at least about this stuff. Perform back of the envelope sketches with respect to four resources: network, disk, memory, CPU, and their other main uh, characteristic: bandwidth, latency. Sketches are cheap. Use sketches to be roughly right and land with 90% of global maximum. Yeah, like this is all like this also applies to basically every problem when you think about it. Like every program needs to or should worry about network, disk, memory, and CPU, and also bandwidth and latency. But again, like you need to be in that mindset to even like consider these important. So when you are writing in lower level languages, when you need to like manually manage the memory, like you will at least get some kind of um, like idea about the memory. Like that's why it is important to learn about Zeek or C or C++ at least. So you know that when you need to allocate the memory, you need to write a line. So it's not like in JavaScript where you can copy and shallow copy and deep copy all the objects whenever you want, because you don't really see the performance like hit for it, and you will get away with it because computers are fast, right? So let me adjust the camera a bit. Yeah. But we are not um, we are not simply trained for that, or not really trained, but exposed to it. So there are multiple groups of developers. That one group is like or not. It's not like every group of developers is like mutually exclusive with each other, but they overlap. But usually you like very few developers have like understanding of all of this stuff, and always keep it in mind when they try to build something. So usually when you try to build something, you will go, okay, I need to implement some kind of function that will do some data operations, render something on the screen. You will go and do it like sequentially, but rarely you will like think about it from design and bandwidth and network and disk and CPU perspective, which again, like it's nice to be like reminded that we can do it and we should do it. Optimize for the slowest resource first. This one is interesting. Network, disk, memory, CPU in that order after compensating for the frequency of usage because faster resource may be used many times more. For example, memory cache miss may be as expensive as disk f-sync if that happens many times more. Yeah, like this one is really good for get like when you want to think about it, like starting from network to disk to memory to CPU, like network is the slowest, disk is the second slowest, then memory, and then CPU. But I'm trying to like at least get some examples for myself at least where this mindset can be applied, because not all problems are not all problems are approachable in this way, or it is not worth to approach them in this way, I guess. But that only applies for some one-off scripts. When you are trying to build a software of any kind, basically, you should always think about this, because I think this is the counterpoint to the movement where everything should be scalable and auto-scalable, and you shouldn't really worry about, oh, we have a network problem, okay, we will spin up more instances so we can output more, or oh, we have a bandwidth problem with our database, oh, let us auto scale that. We have a problem with memory, okay, we will increase the memory size. Like it's like this is talking about the speed. I was talking about the like capacity, but I think that's the mindset that is basically preventing you from thinking like that. The thing is, like, it's 2025 and single machine can do wonders if you optimize it for the thing. So that's I think the reason the Target Beetle is shining in that space, because they're just hyper optimized for their use case, which makes sense. And they can do, like, if they have let me see if they have some benchmarks. Yeah, like this is something, I guess, like this is something you will get if you really think, if you really pay attention to performance. Like I can verify these claims, but I can believe that they can get much more out of one single machine with their software when it is compared to some general purpose database, which is nice because they can save a lot of costs on hosting. It is like there is so many, there is there isn't really a negative or con when it comes to performance. Like, performance is king. Like, if you have to choose if you want more performance or not, and you can choose, and it, like, I guess in their case, like, it is not ruining the project they when they try to get more performance out of it. Like, it's always the win. It's always win. Yeah, so distinguish between the control plane and the data plane. A clear delineation between control plane and data plane through the use of batching enables a high level of assertion safety without losing performance. Okay, so let me Okay, so this is the video. Um, amortize network disk, memory, and CPU costs by batching access. Yeah, like the batching is big one. Yeah, I agree. Like this is something that even every web developer can can at least think about and take away from this. Like batching. So when you think about it, batching is the easiest way to get more stuff done per one unit of some kind of transfer. So that's really nice. Let the CPU be sprinter doing the 100 meters. Be predictable. Don't force the CPU to zigzag and change lanes. Give the CPU large enough chunks of work. This comes back to batching. Yeah, okay, that makes sense. Be explicit. Minimize dependence on the compiler to do the right thing for you. Yeah, but yeah, yeah. This also comes down to like knowing your tools, right? So if you are writing C code, you should at least have an idea like what kind of code is emitted in the end when you compile your code. Same thing apply with Zik, I guess. But in Zik's case, I think they are pretty transparent. And you have in Zik, from what I understand, you have a lot of tweaking tools to generate the code you want to see. So like inlining loops and all of this stuff, like it's pretty nice to have it in your toolkit and use it if it makes sense. And that's really where you can squeeze the extra performance when you use all these tools. And I can imagine that Tiger Beetle is using all the tools to squeeze the 10,000x or 1000x performance gains. In particular, extract hot loops into standalone functions with primitive argument without self. Do we have example? Extract the hot loops into standalone functions with primitive arguments without self. Oh, okay, I see. So basically we'll create... that's interesting. But why? So what they are advocating for is you would... So you should be able to create a struct in Zik and then like attach methods to it, right? Something like Go does. But what they are saying that you should extract the function because the values merge will like work with let's say like only arrays, like there is no structure self argument, but it will return the merge result. Yeah, but I would like to know why. Extract hot loops. Like this makes sense, but maybe they can inline it. I'm not sure like if it's if it makes a difference that much. That way the compiler doesn't need to prove that it can cache structs fields into register and human reader can spot redundant computation easier. Compiler doesn't need to prove that it can cache the struct fields. That's interesting. So like this is the answer, but I'm not sure if I Like this is some kind of like compiler stuff where the compiler can decide what to cache or not, or when to cache and what to cache. This is interesting. So does this apply to all like compilers and languages or not? Or this is specific only to Zik? Like that's the question. Yeah, and dependencies. This is what we have already read. And the last stage. At the end of the day, keep trying things out, have fun, and remember it's called Tiger Beetle. Not only because it's fast, but because it's small. Yeah, that's great. And here we have also like quote from John Carmack. The right tool for the job is often the tool you are already using. Adding new tools is a higher cost than many people appreciate. Yeah, and that's the dependency question, to take the dependency or not to take. Okay, I think that was it for today. I enjoyed going through the article and the Tiger Beetle design or style doc. And I see you in the next live stream. Bye bye.